Welcome everybody to the session of statistics for the topic of hypothesis testing. Step 4. Formulate a decision rule. One-tail versus two-tail test. Let's remind ourselves about hypothesis and hypothesis testing. A hypothesis is a statement about the value of a population parameter, the population mean or the population standard deviation, developed for the purpose of testing. A hypothesis testing is a procedure based on simple evidence and probability theory to determine whether the hypothesis is a reasonable statement or not. Hypothesis testing has 6 steps, and in this one session we are focusing on step 4. Formulate a decision rule. A decision rule is a statement of the specific conditions under which the null hypothesis H0 is rejected and the conditions under which it is not rejected. At the same time, the decision rule will also tell us in which conditions we either reject or not reject the alternate hypothesis as well. Now, how do we do this? We do this through the critical value. The critical value is the dividing point between the region where the null hypothesis is rejected and the region where it is not rejected. So now, we have 3 different cases for this. This critical value is based on the level of significance. Level of significance we see is part of step 2, the alpha from our exercise, the level of risk. The critical value is a dividing point between the region where the null hypothesis is rejected and the region where it is not rejected. And we have 3 different cases here. We'll see all of them slowly in a minute. So now, just quickly here to see it, you have the one case where you're testing the lower tail. And this lower tail is divided into 2 by the critical value. Critical value is this one line that separates the do not reject H0 from the reject H0 region. Now, in this middle case, you have 2 lines here. We have 2 critical values. And this critical value separates the do not reject H0 from the reject H0 areas. And we have 2 reject areas because we have 2 tails. And in the third case here, as you can see, we have a line here. This is a critical value that separates the do not reject zone from the reject H0 zone. So let's see all of these 3 cases one at a time. Now, for any of these 3 cases, if the test statistic, which is step 5, and we will see that in a different video, is greater than or less than the critical value, if you are in the region of rejection, then you reject the null hypothesis. Case 1. The case 1 is when we test one tail, and it's the upper or right tail. How do we know that we're in the upper or right tail? From the setup of our step 1. If the alternate hypothesis, H1, is testing for more than, then we're on the upper tail. Okay, more than, if you see it, the symbol is pointing to the right. So we're going to have a critical value, and this critical value, where do you place it, is taking into account the level of significance, your alpha. So let's assume that for this particular case, our alpha is equal to 0.05. So this critical value here separates the 0.05 area to the rest. Now, if you have 0.05, the other side is 1 minus 0.05, which is equal to 0.95. The area under the curve is 1. Remember, probabilities between 0 and 1. 1 is when you have all of your possible outcomes. And H0 and H1 are collectively exhaustive. If you don't remember that, please review our step 1, which means that if you have 0.05 on one side, then the other side is 1 minus 0.05, which is 0.95. All right, how do we set up this critical value? Well, from our step 3, you were supposed to figure out before getting into step 4 whether you were using Z or the T distributions. And how do you know whether you use Z or T? Is if you have the standard deviation of the population. And if the answer is yes, then you do Z, and if the answer is no, you use T. So let's assume that we do have the standard deviation of the population and we're using the Z table. Okay, so for this one example here, they're giving us the critical value of 1.65, but why? Okay, so let's check it out. We just said that we have a curve and we have at this section here 0.05. On the Z table, we always get the area to the left. So what is the area to the left? Is 0.95. Now area is the numbers in the middle. So let's look for 0.95, and 0.95 is right here, 0.95. So that matches our, let me get the highlighter. Oops, sorry. 1.6. Oh, actually, I'm one off. See, 1 point, this one is closer. See it? So it's this one. So 1.65. And that's what we're getting here, 1.65. That's our critical value. Okay, let's see the second case. The second case is where we go on the lower or left tail. How do we know when we're on the lower or the left tail? When H1 is testing for a less than. And we're having a less than test. And if you see, it's pointing to the left. So, assuming again for this exercise that our alpha is 0.05, so I have here 0.05, which means on the other side, you will have 0.95. So we'll go and check it out on the Z table for the area to the left, that is 0.05. Points, remember area is the numbers in the middle. So area 0.05, this is the closest to it, 0.05. This is a little bit less than, and this is way too more. So 0.05 is negative 1.6, and the second decimal is 5. So now, why is it negative? Because we're on the lower tail, right? So for the Z value, in the middle, Z is always 0. And on the upper tail, the Z value is always positive. And for the lower tail, the Z value is negative. So we get a negative 1.65. Okay, so now, if you see from the one before, let me erase all these writings I have here, right? You have here 0.005, and the one we just finished, we have 0.05 again. So the Z table is symmetric. That's why you have one is 1.65 positive, another one is negative. It just depends on which side of the curve you are. And this critical value separates the do not reject H0 from the rejection of H0 zone. Okay. All right. And the third case is when you're having that the H1 is testing for something that is not equal. So equal and not equal. That's when you have two tails. Okay. Two tails. Now, when you have two tails, and assuming that you have an alpha of 0.05, since you have two tails, you have to divide the alpha by 2. 0.05 divided by 2 is equal to 0.025. And it's 0.025 for both tails. Okay, so now looking at the Z value, okay, because we are assuming here that you have then the standard deviation of the population. Let's go to the Z table and let's look for the area. To the left, remember you had the one curve, and the area to the left, the smallest tail was 0.025. So let's look for 0.025, and it's exactly here, ladies. Remember, the area is in here, and then your Z values are your axis. So the Z value that matches this is 1.9, negative 1.96. Okay, so this is what you have here. 1.96 negative and 1.96 positive. Remember, this is the Z values are symmetric. So one is negative and one is positive because they're in both sides of the curve. Okay, so this critical value here and this critical value here is plus or minus 1.96. Why is it different from the other two where you had 1.65 positive or negative? Because when you have two tails, you are dividing your sigma, I'm sorry, your alpha, your level of significance by 2. The area in the middle is 0.95. Now, this critical value separates your do not reject H0 from the reject H0 in the corners, the region of rejection. Remember, this critical value separates, divides, is the point where you have the area of rejection and the area of not rejection of the null hypothesis H0. And this critical value is based on the level of significance, your alpha. When you only have one tail, when you're testing, for example, the upper side, this is when your H1 is testing for the mean or your standard deviation to be more than a particular number. Okay, as soon as you see more than, you're on the upper tail. And your full area of the tail depends on how big your alpha is. If you're testing your alternate hypothesis for a mean that is less than a particular number, as soon as you see less than, you are on your lower tail. And this lower tail is going to be as big as your alpha, whatever alpha is. And then you're going to have your do not reject zone from your reject H0 zone. If your alternate hypothesis is testing for equal and not equal to something, then you have two tails. And in these two tails, you're going to have that the size of the tail is going to be equal to the alpha divided by 2 because you have two tails. Okay, and that critical value will separate your do not reject zone from the rejection zone, and you will have two rejection zones of H0. Okay, and again, this critical value, the value of Z or T, if you have or not have your standard deviation of the population, okay, will be selected according to the alpha value. Okay, now once you have figured out your descent rule, the areas of rejection and not rejection, then you will do your test statistics, which is your step 5, which you will see in a different video. And if this is greater than or less than a particular critical value, if you are in the region of rejection, then you will reject your null hypothesis. Okay, and this is how you do your decision rule, how you formulate your decision rule for step 4. Hope this helps. Have a great day, and thank you, everybody. Bye.